And your daily math today is a practice quiz for Friday. These are very similar to the questions that you're going to see on your quiz Friday. So I want you to really pay attention to the questions. Make sure you got them correct. If you missed something, I want you to go back and work it and make sure that you can get the correct answer. And if you can't, or you're still confused about something, then we need to take care of it tomorrow so that you're ready for your quiz on Friday. So the first question is asking you to find all the factors of 44. So we'll do that first. I know always 1 times itself will be a factor. So 1 times 44 equals 44. 44 is an even number. So I can do 2 times something to get 44. Half of 44 is 22. I'm going to test and see if 3 is a factor. Well, 3 times 15 equals 45. So 44 cannot have a factor of 3. Next, I'll go to 4. 4 times 11 equals 44. So 4 and 11 are factors. Check 5. Remember, for a number to have a factor of 5, it must have a 0 or a 5 in the ones place. So 44 will not have a factor of 5. Next, I'll test 6. 6 times 7 is 42. And 6 times 8 is 48. So 6 isn't a factor. We just found that 6 times 7 was 42. So 7's not a factor either. 6 times 8 was 48. So we know that that won't be a factor either. Okay, if I check 9's, 9 times 6 is 54. That's too much. 9 times 5 is 45, so that's not going to work either. I'll check 10. For a number to have a factor of 10, it has to have a 0 in the ones place, and 4 is definitely not a 0, so 10 will not be a factor. Next, we come to 11, and we already have 11 listed, 4 times 11, so we've found all the factors. The factors of 44 are 1, 2, 4, 11, 22, and 44. Next, we'll find the factors of 70. Once again, we're going to start with 1. We know 1 times 70 will be 70. 70 is an even number, so I can do 2 times something to get 70. Well, half of 70 is 35, so we'll have 2 times 35. And if I check for 3's, I'm going to erase these up here. Okay. So I know that 3 times 20 is 60. So then I'd have 63, 66, 69, 72. So 3 will not be a factor. Okay. If I do 4 times 20, that gets me 80. If I do 4 times 19, if I count back 4, 76. 4 times 18, count back 4 more, that's 72. Count back 4 from that, and that's going to be 68. So I skipped right over 70. So 4 is not a factor. Okay, next I'll go to 5. Well, 70 ends in a 0, so I know that 5 will be a factor. So 5 times what equals 70? We know 5 times 12 is 60. So I'm going to need 2 more 5s. It'll be 5 times 14 to get 70. Next, I'm going to go to 6s. If I do 6 times 10, that gets me 60. 6 times 11 is 66. And then 6 times 12 is 72. So 6 will not be a factor. Okay, next I'm going to check 7. Well, we know 7 times 10 is equal to 70. So 7 and 10 will be factors. Okay, we've got 7, so now we're going to go to 8. 8 times 10 is 80. 8 times 9 is 72. And 8 times 8 is 64. So 8's not going to be a factor. We just found 8 times 9 was 72. So we know 9 won't be a factor. And we have 10 listed already. So we found all the factors of 70. The factors are 1, 2, 5, 7, 10, 14, 35, and 70. Remember when you're finding factors not to be lazy, and make sure you go through all the numbers so that you find each factor. Okay. Next, we're going to be rounding. We're rounding the number 624,875. First, we're rounding to the nearest hundred. So I'm going to look at my hundreds place. If I go to the next smallest place value, which is the tens, I have 7 tens, and that tells me I'm closer to 900 than to 800. So I'll keep the 624,000. The 8 will go up to a 9, and my tens and ones will become 0. So my answer is 624,900. Next, I'm rounding, same number, 624,875 to the nearest thousand. So I have 624 thousandths. I'm going to look to my hundreds place value. I have an 8. 800 is closer to 5,000 than it is 4,000. So I'll have 625,000. And then we're going to round 624,875 to the nearest 10,000. 62 10,000ths. I'm going to look to my next smallest place value, which is the thousandths place. I have a 4 that's not above the midpoint, so it's closer to 620,000. Alright, for the next question, we are dividing by powers of 10. 80 divided by 8 equals 10. We could also think of it as 8 times 10 equals 80. Okay, the next one we're solving for A. Have 800 divided by A equals 80. So there's a couple different ways I could look at it. I know that to get 8 divided by something to equal 8, that would have to be 1. And I'm going from my hundreds place value down to my tens place value. So I'm going to need 1 0. I could also think of it as 80 times what number? That will represent A, equals 800. I know 8 times 1 equals 8. I have 1 0. In my factors, I need 2 zeros, so I'll have to make that a 10. So remember, there's a couple different ways that you can look at that. When we're dividing by powers of 10, we're getting one place value smaller each time. Okay, next we have 8,000 divided by 80 equals B. Well, 8 divided by 8 is 1. I have 3 zeros, which is the thousands place. I'm getting one place value smaller. That's going to take me to the hundreds. So B will equal 100. We could turn it around as a multiplication problem and say 80 times 100. 8 times 1 is 8. I have 1, 2, 3 zeros in my factors, so my product would be 8,000. Two different ways to solve that one. And for C, we have 80,000 divided by C equals 800. To get from 8 to 8, I'm going to have to do 8 divided by 1. I have 4 zeros in my number here. I need to get down to 2 zeros. So I know that I'll need 2 more zeros in C. So C will be equal to 100. I can look at that as 800 times what equals 80,000. I know 8 times 1 will equal 8. I have 2 zeros in my factor. Here's those 2 zeros in my product, so I'm going to need 2 more. 800 times 100 equals 80,000. Okay, so for A, we have 10. For B, we have 100. And for C, And for C, we also have an answer of 100. Next question, we're completing a table. We're converting yards to inches. So we're going to make a function machine and figure out what our rule is. So we're going to put the number of yards in. We're going to find our rule of how it changes, and then we will get the inches out. I'll go ahead and write inches instead of IN abbreviation. That might get kind of confusing since that's actually the output. All right, so if I put in 4 yards and I get out 144, or if I put in 5 yards and I get out 180, I know my numbers obviously are getting bigger. An inch is a much smaller unit than a yard. It takes a lot of inches to make up a yard. So we've got to figure out what in the world we're going to need to do to change that. So I know I'm getting bigger. I'll either add or multiply, but since I'm converting yards to inches, I know I'm going to be multiplying. So I'm looking for 4 times what number gets me to 144. 5 times what is 180. I'm going to solve using that 5 because it's a lot easier to work with multiples of 5. So to find a missing factor in a multiplication problem, I know I can turn that around to a division problem, and I could do 180 divided by 5 equals something. So I've got 180, I'm dividing by 5. Well, I can't put one thing into 5 groups, so I'm going to move my 100 over to the tens. That gives me 18 tens. As close as I can get is 5 times 3 will get me 15. So I'll have 3 left over. I'm going to move those 3 over to my ones. So now I have 30 ones. And I know that 5 times 6 gets me 30. So 5 times 36 equals 180. I can test that out. I need to make sure that 36 works. So I can check my work here by doing 4 times 36. Okay. So I can do 4 times, let me move this over. 4 times 36. I'm going to do 4 times 30. And then 4 times 6. 4 times 30, 4 times 3 is 12. I need one more 0, so 120. And 4 times 6 is 24. So if I add those together, 120 plus 124, that equals 144. So I see that my rule is correct. I am multiplying by 36 each time. So to find A here, I'm going to drop in 6. It's going to go through the machine. So I need to do 6 times 36. So I'll do 6 times 30 and 6 times 6. 6 times 30, 6 times 3 is 18. And I need to put my 0 at the end. 6 times 6 is 36. And if I add those together, I look at my ones. 6 plus 0 is 6. If I add the tens now, 8 plus 3 is 11. I'm going to put my 1 in the tens place and carry the 1 over to the hundreds, and 1 plus 1 is 2. So A is going to be 216 inches. That will be what comes out. Now I need to solve for B. So I'll put a 7 in, and we'll do 7 times 36. And break that apart into 7 times 30 plus 7 times 6. 7 times 3 is 21. I need a 0 at the end. Then I have 7 times 6. That's 42. And if I put those together, I will get 252. So B equals 252. Right. Next question, we're converting measurements again. We're going from pints to cups. Takes 2 cups to make a pint. We'll multiply 3 times 2, and 3 times 2 is 6. So there are 6 cups in 3 pints. To solve for B, we need to convert 10 cups to pints. So we'll divide by 2. 10 divided by 2 equals 5. 10 cups equals 5 pints. Okay. Next, we're looking for the equivalent fraction that those models represent. Remember, for us to be able to compare fractions, we have to make sure that the whole is the same size. Remember, we can't compare a small pizza to a large pizza. So we look at those two wholes and they are the same, so I can compare. In this first one, excuse me, in my first model, we have 1, 2, 3 pieces shaded. There's 4 pieces in the whole, so this model represents 3/4. I can see that I have the same amount shaded on this second one. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces shaded. That'll be my numerator or top number. There are 10, 11, 12 pieces in the whole, so 12 is my denominator. So 3/4 is equal to 9/12. That would be option number 4. Let's look at that mathematically. I want to show that 3/4 is equal or equivalent to 9/12. So if I wanted to go from 3 to 9, I could do 3 times 3. Whatever I do to the numerator, I also have to do to the denominator. So we'll multiply by 3/3. 3 times 3 equals 9, and 4 times 3 equals 12. So we've mathematically proved what our model shows as well. If we go on to the next problem, wants to know which model correctly represents the problem. We have some fractions to add. We know when we're adding or subtracting fractions, our denominator or bottom number has to be the same, and it is for all 4 of our options. Excuse me. So we're ready to add 6/9 plus 7/9. Well, 6 plus 7 is equal to 13, not 15. So option 1 can't be true. 6/9 plus 7/9. 6 plus 7 is 13, not 12. So option 2 is not correct. Okay. 6/9 plus 7/9 does not equal 1/9. So option 3 is incorrect. Okay. Option 4, we have 8/9 plus 7/9. 8 plus 7 equals 15. So 15/9 is correct. Let's look at 15/9 and make it into a mixed number. If I take out a whole, it takes 9/9 to make one whole. To get 9 back to 15, I would have to do 9 plus 6. So as a mixed number, 15/9 is equal to 1 whole and 6/9. We have that. And our model shows 1 whole and 6/9. So option 4 is the correct answer. All right. I go on to number 9. I have a 2-digit multiplication problem. 63 times 98. I'm going to set up an area model. So my short side is going to be 63. I'll break 63 apart into 60 and 3. I'll break 98 apart into 90 and 8. And now I'm ready to multiply. I'll do 60 times 90 to find the area of that section. 6 times 9 is 54. I have 2 zeros. To find the area of this next section, length times width, 60 times 8. 6 times 8 is 48. and I have 1 0. Moving on to the next part, I'm going to do length times width. 3 times 90. 3 times 9 is 27, and I have 1 0. And for the last section, length times width, I have 3 times 8, and 3 times 8 is 24. So now I'm just going to add those together. If I add 24 and 80, that makes 100. If I add that, I'm sorry, 104, don't forget that 4 there. If I add that to the 400, I now have 504. And 504 plus 270 is going to get me to 774. Now I need to add the 5,400. So let me write that down. If I add my ones, I have 4 ones, 7 tens, add my hundreds. 7 plus 4 is 11. I'm going to regroup the 1 to the thousands, so I'll have 6,174 is the correct answer. Okay. Next, I'm using the distributive property to solve 5 times 47. Let's look at 5 times 47 in an area model. If I were going to solve 5 times 47, I would make my short side 5, the long side would be 47, and I would break that apart into 40 and 7. So if I look over here to see what's missing for A, I have 5 times 7, so I'm missing the 5 times 40. A is going to be equal to 40. Now I would solve 5 times 40. 5 times 4 is 20, and I need one more 0. So B will be equal to 200. 5 times 40 is 200. 5 times 7 is 35. So C will be equal to 35. And then I just need to add 200 plus 35. And that equals 235. So D is 235. Okay. We'll look at number 10. Select the diagram that matches this problem. There were 54 cookies on the counter. That is 6 times the number of cookies in the oven. How many cookies are in the oven? All right, so let's look at that. At this problem, there were 54 cookies on the counter. That goes back, it's talking about the 54 cookies. So 54. Then we have this word is. We know is represents the equal sign. 6 times the number of cookies in the oven. And that's what's missing. We need to know how many cookies are in the oven. So I'm just going to use a C for cookies that are in the oven. So if I take the equation that we just wrote based on the problem, 54 equals 6 times C, and I may turn that around so that my unknown, or the number of cookies in the oven, is by itself, I would do 54 divided by 6 to equal the number of cookies. I know that 6 times 9 equals 54, so 54 divided by 6 equals 9. So there will be 9 cookies in the oven. So we're going to look for the answer that shows that. Remember, there were 54 cookies on the counter. Well, in our first option, it shows there were 9 cookies in the counter. So that's not correct. If I look at option 2, the counter, there's 1, 2, 3, 4, 5, 6 groups of 9. 9 in the oven. They have the equation 54 divided by 6 equals 9. There are 9 cookies in the oven. Option 2 is your correct answer. We're looking for the model that correctly represents the problem. If I look, all 4 of my options have the same denominator, so we're ready to subtract. 7/12 minus 1/12. 7 minus 1 is equal to 6, not 5. So option 1 cannot be correct. Option 2, we have 7/12 minus 2/12. 7 minus 2 equals 5. So that is correct. Our denominator stays 12. If I look at the model, we started with 1, 2, 3, 4, 5, 6, 7 parts shaded. So that's correct. There are 8, 9, 10, 11, 12 pieces in the whole. That's correct. We have 7/12. It shows to take away 2/12, and we can see that there were 2 pieces that were being taken away, and there are 5 left. So option 2 is the correct answer. All right. And we're looking for the model that represents 3 and 5/8. So I have 3 wholes and 5/8 more. And I'll need to take away 1 whole and 7/8. And so if I look at all of my models, option 1, we started with 1, 2, 3 holes shaded, but there's only 1, 2, 3, 4 of the 8 shaded in the last one. So option 1's not correct. Option 2, we've got 1, 2, we could take 2 of these 2 pieces and move them over. That makes 3 holes, but then I would only have 3/8 more shaded, so option 2 is not correct. If I look at option 3, I have 1, 2, 3 holes, and then I have 5/8 more, so the shading to start with is correct. I need to take away 1 hole and 7/8. Okay, so I can see that they've taken away all but 2 pieces of a hole here, so I could just move these 2 over. There's my 1 hole. I need to see if there's 7/8 more. 1, 2, 3, 4, 5. They just took away 5/8, not 7/8. So option 3 is not correct. I look at option 4. I have 1, 2, 3 holes, and then there are 5/8 shaded, so that's correct so far. I need to take away 1 hole. They did that, it's crossed out. And 7/8 more. 1, 2, 3, 4, 5, 6, 7 out of the 8 pieces were taken away. So that is correct. Option 4 is the correct answer. I have 1 hole left. Here's 1/8. If I put that with the 5/8 that we have in that last model, 1 and 6/8 would be the correct answer if we needed to solve. Right. A bag can hold 9 tennis balls. The factory needs to equally place 835 tennis balls in bags. How many full bags will there be? So I have 9 tennis balls can go in each bag, and we have 835 tennis balls to put into the bags. So to solve this, we need to divide the 835 tennis balls into bags or groups of 9. All right, so I have 835. I'm dividing by 9. Well, I can't put 8 things into 9 groups, so I'm going to need to move my 800s and make them into 10s. That gets me 83 10s. So I'm looking for 9 times what gets me as close as I can get to 83. So I'm just going to go ahead and list my 9s. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. 9 times 6 is 54. 9 times 7 is 63. 9 times 8 is 72. 9 times 9 is 81. 9 times 10 is 90. So remember, I'm trying to get to 83. 90 is too much. 9 times 9 equals 81. So I could put 83 things into 9 groups 9 times. That would use 81 of them. So I have 2 left over. I'm going to move that 2 over to my ones. Now I have 25 ones. Looking for 9 times what gets me as close as I can get to 25 without going over. Well, 27, 9 times 3 is 27. That's too much. So I'm going to have to go back to 9 times 2. 9 times 2 is 18. So I'm going to have 7 left over. 835 divided by 9 is 92 with a remainder of 7. So let's go back and look at our question. The question says, how many full bags will there be? Well, we can make 92 full bags, and then there's going to be 7 extra tennis balls. So for the next question, we have the exact same story. A bag can hold 9 tennis balls. The factory needs to equally place 835 tennis balls in bags. How many tennis balls will there be in the last bag that isn't full? So we made 92 full bags, and then we had a remainder or leftover of 7. So there will be 7 tennis balls left. And the last one, which model best represents the answer to this problem? We have 5/6 times 3. So I'm making 3 groups of 5/6. I could also think of that as 5/6 plus 5/6 plus 5/6. 5 plus 5 plus 5 is 15. My denominator will stay 6. I could also multiply 5 times 3. My numerator times 3 is 15. And my denominator stays the same and get the same answer either way. I need to take 15/6 and make that into a mixed number. So 6/6 makes a whole. I could get another 6/6 to make another whole. 6 plus 6 is 12. And then I would have 3/6 left over. So my answer would be 2 and 3/6, or 2.5. And if I look at my options, I can see that option 4 has 2 holes and 3/6 shaded.